Welcome everybody, this is Schwab again. Today I'd like to start a series of presentation linked to resistance. Before going to real flow resistance, first let me give you an analogy, and I'm seeing a very nice analogy between the flow resistance and the resistance which is observed in the wires when the electricity flows through the wires, and that has been described long time ago by so-called Ohm's law, and we can discuss a very simple geometry here. Look, imagine that this is a wire made from aluminum, cuprum, or simply any other metal. There is a certain current flowing through that wire. Well, that of course can be happening only if we have a certain voltage between the both ends. Because why? Because the electrons, to pass through that wire, they need to overcome some sort of resistance. You can also say that the electrons will flow only if we impose a certain voltage. Then we have the current, and the proportion between the current and the voltage is called resistance. So every wire is a resistor, and it is clear that the resistance of the wire is the property of the material, because aluminum, cuprum, gold, we know that they create a different resistance to flow of the electrons. So with the same voltage, you can get a different current for aluminum or cuprum. At the same time, however, the diameter of the wire matters. We know that if we make the wire thicker, twice as thick, we lower down the resistance of that segment. So if we make, let's say, the lower part of the channel thicker, we lower down this resistance for the whole system, because the resistance of the whole system is sum of the resistance of this narrow part and the resistance of this thicker part. That of course influences the voltage and current going through. Similarly, we can do something different. We can just have the thickness here. So these two will probably give us the same resistance. We also can try to say, well, if I, let's say, make this part thicker, can I just get the same resistance in the upper section? Well, of course I can get the same resistance by material, but is there any geometrical property or parameter which I can change? Well, that's probably the length. If I make it longer, I can reach here the same flow resistance as I have here, or electricity resistance. That's what we've tried to do here. This is how much you have to make the wire longer. So we see here that we have several parameters which influence the overall resistor properties. That is the material used, and also the overall diameter, or I would say the cross-sectional area, and also the length of the resistor. So these are the things we can play with, and that way we can influence the resistor properties. Well, similar situation we observed that this situation with electric cables, it was just analogy, but we observed the same situation with flow of the polymer. If we just look at the flow in a simple pipe, right, where we have an entrance of certain mass and exit, we of course can get any flow only if there is a pressure drop, or you may say if there is any pressure drop we get the flow. And we get the pressure drop as a result. Well, the pressure drop is simply equivalent to our voltage, and the flow coming through, that's our current. So apparently the ratio between them can be called a resistance. We see that the flow has a resistance similarly as the wires or electrons have resistance in the wires and in the cables. And we can now start thinking about the flow as a certain network of resistors. We will see that in the next presentations too. Now, can we somehow influence the resistance for the flow? Sure, similarly as we did it with the electric cables. For example, if we just open this section, you see the pressure drop here is much lower than it was before, while the pressure drop there is still very high. Here it has been decreased significantly. So we really decrease the resistance of this section by opening the diameter. We can do similar thing by opening the other part. right? So these two sections, of course, would be having total pressure the same. Now, we can also ask how much do we have to make this longer to have in this upper section the same resistance as in the lower section. Well, I've solved this situation here, and you can see that it has to be much, much longer than the other part. So the length doesn't have so much effect on the resistance. But at least we can see now that the resistor can be having a different shape, different diameter, different length, and still give us the same resistance. We also can see that we have several properties here to play with. We have the polymer viscosity as the major property of the material. We have also the diameter or the cross-section area, which influences the resistance. And we also have the length to play with. So all these factors influence the resistor, and we can now find out how to use that for balancing and for analyzing the flow situation.